Hello students, in this session
Let us solve a question on shear force and bending moment diagram. A beam is loaded as shown. The beam is loaded according to this condition is given that 10 kilonewton load is applied at some eccentricity, 6 kilonewton is inclined load is applied. It will be having two components, 6 kilonewton, one horizontal and one vertical, and this 10 kilonewton will be having the bending moment effect as well as the direct load effect, point load effect, and it is simply supported at P and S. Right? We have to find out the bending moment for this beam at point R point, at this point where this inclined force is applied. This point we have to find out the bending moment, right? So let us solve this question.
this question contains a simply supported beam at P and S. They are simply supports. This is a hinge joint and this is a roller joint, and we are applied with different loads. A 6 kilonewton of inclined load at an angle 30 degree to the horizontal is applied at a 2 meters from the roller joint, and a 10 kilonewton of load is applied at this L-shaped rod with 1 meter from the Q point, right? And we have to find out the bending moment at point R. That what is the bending moment at point R? This we have to find out. So how to do this question? Now you can see here this 10 kilonewton is applied as an eccentricity at 1 meter. So the effect of this 10 kilonewton will be the force of 10 kilonewton, direct point load of 10 kilonewton in vertical direction at point Q, as well as a bending moment of 10 multiplied by 1 means 10 kilonewton meter at point Q, right? So at point Q there are two types of loading. One is bending moment, which is 10 kilonewton meter, and another is point load, which is 10 kilonewton. And this inclined force can be divided into two parts. It can be resolved in two components, that is horizontal component 6 cos 30 and vertical component 6 sin 30, right? And this horizontal component will be reacted by this load P, because there is no horizontal reaction at roller joint. So horizontal reaction will be developed in P point, right? And vertical reaction will be developed at both point P and S, right? So how to solve this question? So let us make a beam, same beam again. Let us make a same beam again. This is our beam PS, and this is here hinge joint. Here it is roller joint. 6 kilonewton can be resolved in two components. One is 6 sin 30 and another is 6 cos 30, right? At point R, at this point R, at this point R, right? And this 10 kilonewton can be divided into two parts, that is 10 kilonewton of point load as well as a bending moment in clockwise direction, because it is clockwise. So bending moment in clockwise direction like this of strength 10 kilonewton meter, right? So this is the loading of this actual loading, which can be seen here, right? So this is Q point and this is R point, this is S point, this is S point, right? So how to find out the moment at this point R? First we have to find out the reaction, and finding the reaction we can take the moment to the right of the section or to the left of the section where it is comfortable, right? So let us say find out the reaction at 2 points, that is RP and RS, right? And also there is a reaction in horizontal direction also, because the horizontal reaction will be taken by this point P point, right? Because hinge joint can take horizontal as well as vertical reaction, so there will be a horizontal reaction also, right? So this is horizontal reaction, say RH means horizontal reaction, RH, right? So, and which is not to be required, which is not needed finding the moment at this point, because this point is passing through this R itself, right? So the moment of RH, the reaction RH will be equal to this reaction will be, RH will be equal to, because the horizontal forces should be equal because the body is in static equilibrium. So horizontal forces, sum of all horizontal forces should be equal to 0. So RH in rightward direction should be equal to this 6 cos 30 should be equal to 6 cos 30 in leftward direction, right? So from here we can find out RH, and that is equal to 6 multiplied by cos 30 is root 3 by 2, right? So RH will be equal to 3 root 3, and it is given in kilonewton, so it is kilonewton. So this is this much kilonewton. This is the horizontal reaction RH, right? Now we have to find out the vertical reactions RP and RS. So how to find out vertical reactions? We can take moment about any point, say P point. We can take moment about P point. So moment, sum of all the moments about P point should be equal to 0 because the body is in static equilibrium, right? So how many forces are there? RH, RP, 10 kilonewton, 10 kilonewton meter, 6 sin 30, 6 cos 30, and RS. 1, 2, 3, 4, 5, 6, 7 forces are there, right? Or moments, right? 7 forces or moments are there, right? So moment of RH will be 0 because RH is passing through P point only. So there is no moment of RH. Moment of RP about P is 0 because it is passing through P point only. Moment of 6 cos 30, 6 cos 30 is also 0 because the action of this 6 cos 30 is passing through P point only. So RH, RP, 6 cos 30, the moment of these forces are vanishes, right? What is the moment of this 10 kilonewton? This is the 10 kilonewton multiplied by the distance, and distance is 2 meters. This distance is 2 meters. All the distances are 2 meters. So the moment of 10 kilonewton is 10 multiplied by 2, and it is clockwise. So 10 multiplied by 2 clockwise. So clockwise we are taking positive. 10 multiplied by 2. The moment of this is itself, because it is itself a moment, 10 kilonewton meter. So it is clockwise. So again it is positive. Positive 10. Now what is left is 6 sin 30. The moment of 6 sin 30 is again clockwise, and that is 6 sin 30 multiplied by this distance, vertical distance, that is the 2 plus 2, that is 4. So this is plus again 6 sin 30 multiplied by the distance 4 meters, perpendicular distance, and the moment of RS is RS multiplied, it is anti-clockwise, so it is minus RS multiplied by this distance, perpendicular distance, that is 6 meters. So this is 6, and that should be equal to 0. So from here, solving it, you will get the value of RS, the reaction at point S, right? So solve it, use calculator and find out the value of reaction. I am writing directly the value RS, 7 kilonewton. So we have find out the reaction at point S point, that is 7 kilonewton. So this is 7 kilonewton. Now we want to find out the reaction at point P. How to find out the reaction at point P? We know that sum of all vertical forces should also be equal to 0 because the body is in static equilibrium. So sum of all the vertical forces should also be equal to 0, right? Or we can say the downward force should be equal to the upward forces. That's why the sigma FV should be equal to 0. What are downward forces? That is vertically downward forces, that is 10 and 6 sin 30. And what is the vertically upward forces? That is RP and RS, right? So we can write that sum of all vertical forces should be equal to 0, or in other sense we can write RP plus RS should be equal to downward forces, that is 10 kilonewton plus 6 sin 30. So 10 plus 6 sin 30, and RS is known to us, that is 7 kilonewton. Use this value 7 kilonewton and find out RP. What is the value of RP? So find out the reaction at point P, that is RP. Solve it and you will get the value as 6 kilonewton. Right? 6 sin 30 is 1 by 2. So that is 10 plus 6 sin 30 is 1 by 2, so that should be equal to 13. So 13 minus 7, 6 kilonewton, right? So we have got the reactions, that is Rp 6 kilonewton and Rs 7 kilonewton. Now we want to find out the bending moment at point R. What is the bending moment at point R? So for bending moment, we can take the moment of all the forces to the right of the section, right? Or left of the section, whatever we want to take. Because to the right of the section, there are less forces, so we can take the moment of forces to the right of the section, right? And you know that the forces acting at the same point, if that force are point load, that will not affect the bending moment, right? Only moment can affect the bending moment at that point. So there is no abrupt change in bending moment due to these forces, right? So we can take to the right of the section, we can take any distance x to distance x, and we can find out the moment at this point x, and then we can find out the distance moment at point r, right? So moment at point x will be equal to, that will be equal to 7x, right? And it will be valid between s to r. This will be valid from s to r. So we have to find out the bending moment at point s. So at point s, ms, that will equal 7 multiplied by the distance, because at s point, the value of x is 2 meters. So we have to find out at 2 meters. So this is r basically, mr. So that is equal to 7 into 2, that will equal to 14 kilonewton meter. So if we want to find out in Newton meter, then we can find out mr will be equal to 14,000 Newton meter. So this is the answer of this question. 14,000 Newton meter.